Hello everyone, I am Sandeep Kumar. In today's video, we are going to discuss about the sum of subsets problem based on backtracking in the subject design and analysis of algorithms. The sum of subsets problem can be stated as follows. When given a set of positive integers and a target value, we want to find all subsets of the set whose elements sum up to the desired set of target. That is, as shown in the picture, let's say we are given a set of the elements 1, 2, 4, 6, and 8, and the desired sum is d, that is 10. Our goal is to find all combinations of numbers from the set w that add up to 10, which is the desired sum. Now let's understand how the backtracking works. At each level, we decide whether to include or exclude the current element. That is, going through all the elements of the set, we decide whether it should be included into the sum or excluded. This helps in generating all possible combinations of subsets from the given set of elements. And if the running sum exceeds the desired sum, we backtrack. That is, we return to the previous state and try other option of or either including or excluding the element. This way, we avoid unnecessary computations, which will lead to more time complexity. Now, looking at the tree shown in the picture, the root node starts with the sum 0. At each branch, we either include the element, that is, we add it to the sum, or exclude the element, keep the sum as it is from the previous state. We continue this recursively until we either reach the desired sum, which is 10 in this example, or exceed it. When we hit the target sum, we record the path that the path corresponds to one valid subset. In this case, subsets like 2, 8 or 4, 6 will be found based on the starting element choice. In this example, we start with the first index, current sum is equal to 0, recursively exploring including the current element. From the current element, we explore all the elements recursively. If at any point the current sum exceeds the desired sum, we backtrack. Coming to the complexities, backtracking improves efficiency compared to brute force subset generation. But the worst case time complexity can still be exponential, which in this problem goes up to 2 power n, where n is the number of elements in the set given. Summing up the video, backtracking is a powerful method for solving subset related problems. The sum of subset problem teaches us how we can avoid redundant computations by cutting off unpromising paths early. That's all for today's videos, guys. Thank you.